So now in this video, we have an op-amp comparator here. The output is high right now because our signal has a higher voltage than our reference voltage. When I turn the lamp off here, then you can see that the output went low. Blue LED lit up because the signal voltage went down. So now this is adjustable. I did that with the 3K resistor in series with the light dependent resistor. So a lamp at the dimmest setting sets the output low, but any bit higher than that, I just went up to the next higher setting and the output will go high. So now we're going to look at the schematic diagram for my light dependent resistor controlled op-amp non-inverting comparator. So we have a reference voltage right down there, and I zoomed back for those watching the shorts, and now we'll zoom back in for a better look. And then our signal voltage coming to the plus input, the non-inverting input. Now they are in opposite positions on the schematic versus the physical component. Always pay close attention to how the physical component pin layout is. It doesn't always line up with what's on the schematic, and I actually put numbers for the pins. But in any case, we got reference voltage, signal voltage. The op-amp compares the two, and it makes the output more like the non-inverting input right there. And so positive supply output, high output, red LED lights up, and then when the output is low, then the blue LED lights up. Makes a pretty good connection to ground. So now we're going to look at powering this circuit, especially the integrated circuit for the LM358. We have it wired as a light dependent resistor controlled non-inverting comparator right there. So you got the power pins, the pin number 4 there for the ground, negative supply, pin number 8 for the positive supply. I showed that on the schematic, but it may not always be shown on the schematic. And this is the power that comes to the output. So you got some transistors, so you lose a little bit of voltage, but in any case, that's the path there when the output's high, and then ground. And you can see that's when the blue LED lights up. Makes a better connection to ground. But it's powering what's going on inside the integrated circuit, and it's also providing power for the load. So there you can see a positive supply to pin 8, goes up to that jumper, shares that row, and then negative supply to pin 4 right there. So now, of course, for comparator circuits, you need a reference voltage. And since this is a non-inverting comparator circuit, we're using the LM358 op-amp, then the reference voltage goes to the inverting input minus. Now you notice the minus is lower on the schematic right here than the plus. We're on the physical component, we got the plus below the minus right there. They're in opposite spots. Always pay close attention. You got to wire according to the physical component. But in case, we just have a fixed value voltage divider right there, half the supply voltage. And so this will go up and down, above and below half of the supply voltage, and the output compares the two, and it acts more like the plus right there. So there you can see, second pin down is the inverting input, and we got our two 10K resistors, one to the positive supply, one to the negative supply, for half of the supply voltage. So now in this short, we're going to focus on the signal voltage right there. So I'm zoomed back for those watching shorts. We're going to zoom in, and always remember the plus and the minus location on the schematic may not line up with the physical component, as you see here. So we got a voltage divider made up of a light dependent resistor and a fixed value resistor. Higher light, you get a higher voltage, and then less light, you get a lower voltage there. So it depends on which one's higher or lower. The non-inverting input higher, you get a high output. When the non-inverting input is lower than our inverting input voltage, then you get a low output. Pretty straightforward. So there it is. The light dependent resistor, fixed value resistor. This one adjusts the sensitivity. With the 3K resistor down here, if I put my lamp to the dimmest setting, we get a low output. But just up one more spot, we get a high output. So that's going to a pin 3 right there, the non-inverting input or plus. So now, as usual, I'm going to end this series of videos with what the output's doing. So we're looking at the op-amp wired as a non-inverting comparator. When we get a higher voltage, the plus, then minus right there, output goes high, red LED lights up. A lower voltage, then the output goes low. So you can see those two current paths. Make sure you put the LEDs in the right way. But you can see you make this more positive. The red LED is going to light up because it heads to ground. It's not as bright as a blue LED, so lower value resistor. And the opposite with the blue. We get a better connection to ground right there when the output is low. and the blue LED will light up. So you can see we got positive there, so we know the blue LED lights up when the output's low, connected to ground. And the red LED right there, I move my finger away, you can see we got it connected to ground. So right now it's lit up, we know it's coming from the positive supply. If I cover it, now we know there's ground on both sides, so it's not going to light up.